Hi! Today we're gonna discuss the basics of stoichiometry. But first, let me tell you what stoichiometry is. Stoichiometry is a branch of science that deals with the application of laws of definite proportion and the conservation of mass and energy to chemical activities. First from our list is small concepts. One thing we should all be familiarized at is the atomic weight and mass. The atomic weight and mass tells how heavy the element is, and it can be easily seen in the periodic table. In order to find the molecular mass of a compound, we must first find the atomic mass of every element and then multiply it to its corresponding subscripts. After that, add all the atomic masses and express this in AMO.
Now that we're done with the molecular mass, we will now proceed to the molar mass. It is expressed in a unit grams per mole. In finding the molar mass, it's the same with the molecular mass. There are two things you have to remember in the mole concepts: Avogadro's number and the mole concept triangle. The Avogadro's number is the actual number of atoms in every 12 grams of carbon-12. It has a constant value of 6.022 times 10 raised to 23. The mole concept triangle is a brief summary of the conversion methods in this portion.
The triangle tells us that in order to convert mass to moles, you have to divide the given mass to the given molar mass of the given element.
Let's try some examples. Sample number 1. How many moles of atoms are there in 6.46 grams of helium? Step 1. Write the given. Step 2. Divide the given by the molar mass. Always use dimensional analysis to prevent errors. Using dimensional analysis, you can see that in 1 mole of helium, there is 4.002 grams of helium. Dividing 6.46 grams of helium to 4.002 grams of helium will easily get us 1.61 moles of helium. We have to multiply the mass of the given element to its corresponding molar mass according to the periodic table. Sample number 2. How many grams are there in 5.67 moles of H2O? Step 1. Write the given. Step 2. Multiply the given by the molar mass. Use dimensional analysis. Using dimensional analysis, you can see that in 1 mole of H2O, there is 18.016 grams of H2O. 18.016 is obtained by getting the molecular mass of the formula. Input this in your calculator and you can easily get 102.15 grams of H2O.
Always remember, first, find the molar mass. Second, don't forget the designated units. And third, follow the instructed number of decimal places. This tutorial will round off up to 2 decimal places. For most of the number of particles, the triangle tells that we should multiply the moles to the Avogadro's number.
Let's try some examples. How many atoms are there in 0.31 moles of H2O? Step 1. Write the given. Step 2. Multiply the given to the Avogadro's number. Again, use dimensional analysis. Using dimensional analysis, you can see that in 1 mole of H2O, there are 6.022 times 10 raised to 23 atoms of H2O. Multiplying 0.31 moles of H2O to 6.022 times 10 raised to 23 atoms of H2O over 1 mole of H2O will easily get us 1.87 times 10 raised to 23 atoms of H2O. This is the solution on how to get the moles given the number of particles or atoms. How many atoms are there in 2.04 times 10 raised to 26 atoms of zinc? Step 1. Write the given. Number 2. Divide the given to the Avogadro's number. Use dimensional analysis. So 2.04 times 10 raised to 26 is divided to the Avogadro's number. Input this in your calculator and you can easily get 388.75 moles of zinc. In order to convert from mass to the number of particles, first, you have to convert mass to moles. After converting to moles, you can now proceed in converting moles to the number of particles. In converting mass to the number of particles, we'll have to do this step by step. How many atoms are there in 16.3 grams of gold? Step 1, of course, is convert to moles. With step 1, write the given. Step 2, divide the given by the molar mass. Dividing it will give us 0.08 moles of gold. Step 2 is to convert the number of particles using the solved mole. Using 0.08 mole gold, we have to multiply it by Avogadro's number. Multiplying will give us 4.82 times 10 raised to 23 atoms of gold. Following the operations present in the mole concept triangle, you should be able to solve problems easily.
Now that we're done with the mole concept, let's now proceed to the percent composition by mass. Percent composition by mass is defined as the percent of mass of each element in a compound. In doing that, we need to keep this formula in mind. We aim to know in this section how significant or large a certain element is in a compound.
Sample number 1. Find the percent composition by mass of H3PO4 or phosphoric acid. Step 1. Find the molar mass of each element and the total molar mass. The total molar mass is the mass of the compound. Since hydrogen has 3 subscripts, we will multiply it to its molar mass. While phosphorus has only 1 subscript, we won't be multiplying it anymore. And oxygen has 4 subscripts, so we will multiply it to its molar mass. Adding the addends will give us 97.99 grams per mole of phosphoric acid. Step 2 is to use the formula to find the percent composition by mass of each element. This is easy because you only have to substitute what you have in the given formula. Input this in your calculator and you should be able to get the results.
If we look closely, the sum is not reaching exactly 100%. This is because of certain estimations that were made, and this concept only aims to show percentage. In the next portion, there are problems we would need to find the molecular formula of the compound by using the percent composition by mass given per element.
Ascorbic acid has 40.92% carbon, 4.58% hydrogen, and 54.5% oxygen by mass. Assume that there is 100 grams of ascorbic acid and find the empirical formula. So step 1, let's analyze the problem. It tells us that it has 40.92% carbon, 4.58% hydrogen, and 54.5% oxygen by mass. Since that there is 100 grams given, percentage is the grams itself. See that it has 40.92 grams of carbon, 4.58 grams of hydrogen, and 54.5 grams of oxygen. Now that we have grams, let's now convert to moles. Using the techniques we've learned earlier, we can now apply it to this problem. So converting from mass to moles will get us 3.41 moles of carbon, 4.58 moles of hydrogen, and 3.406 moles of oxygen. But this isn't the final answer because we can put this in the final solution or the empirical formula. So step 3, we have to find the smallest value of mole and divide it among other moles because it is a ratio. So finding the smallest value of mole and dividing it to other moles will get us these answers. Notice that there is a 1.33 moles of hydrogen. These are the actual moles of ascorbic acid. Using trial and error, multiplying it to 3 will give us 3.99, which is close to 4 moles of hydrogen. Since we multiplied 1 mole to 3, we have to multiply every moles to 3 because it is all in ratio. So C3, H4, and O3 is the empirical formula of ascorbic acid.